Introduction. Chromatography is a technique that used in separating and identifying the components present in a mixture. It allows the components in the mixture to move between a stationary and mobile phase. Components that are tightly bound by the stationary phase flow slowly with the mobile phase. The components that are weakly held, on the other hand, move fast. Components of a mixture divide into discrete bands due to the difference in mobility, which can be analyzed qualitatively and quantitatively. Gas chromatography is one of the chromatography techniques. It used in separating volatile chemicals as it is vaporized in the room temperature easily. The mobile phase is a gas and the stationary phase is a high boiling liquid that is adsorbed on a solid. Gas chromatography has become one of the most useful instruments in the chemistry due to its ease of use, high sensitivity, and ability to effectively separate mixture. Components of the mixture are dispersed between two phases, which are stationary phase and a mobile phase or carrier gas. Carrier gas moves the mixture through the stationary phase. Compounds in the mobile phase move through while interact with those in the stationary phase. Since each component's properties and structure are different, the size and affinity of each interaction with the stationary phase varies. As a result, even when the driving force is the same, the retention duration of individual components in the column varies, causing them to exit the column in different orders. High-Performance Liquid Chromatography, or Hplc, is a type of column chromatography that allows a mixture or analyte in a solvent to go through a column with chromatographic packing material at high pressure. A moving carrier gas stream moves the sample. Hplc are able to spread and identify chemicals in materials that can be dissolved in a solvent at trace concentrations. Hplc is applied in a variety of commercial and scientific applications due to its versatility. As both the analytes and mobile phase are pushed through the column, separation takes place. On the recorder, each component eludes from the column as a peak. A chromatogram is a visual representation of the detector's response to each component. These are the instruments for gas chromatography and Hplc. For instruments of gas chromatography, it consists of carrier gas, injector, column, detector, and display system. For Hplc, the instruments consist of mobile phase, reservoir, pump, injector, column, detector, and data system.
Methodology. For part 1, which is analysis of vanillin in white chocolate by gas chromatography. Based on the joint determination of vanillin and aldehyde vanillin in milk powder by head-phase solid-phase microextraction, coupled with gas chromatography mass spectrometry, sample preparation and standard preparation were prepared. In standard preparation, there were 3 solutions prepared which were vanillin and ethyl vanillin standard solution, vanillin and aldehyde vanillin intermediate solution, and lastly a series of metric standard working solution. You can pause the video to see the preparation. Next is gas chromatography mass spectrometry analysis. Adlin 7890A5975C gas chromatograph coupled with mass spectrometer with EI source and CTC 3-in-1 autosample was applied to quantify the content of vanillin and aldehyde vanillin. The sample was incubated at 80 degrees Celsius for 40 minutes with a rotation rate at 500 rpm. After incubation, a 65 micrometer DVB PDMS fiber was exposed to the headspace of the heated beer for 40 minutes. The fiber was then dissolved in injection point for 5 minutes. Ultra-pure helium passed through a gas screen GCMS filter and was used as the carrier gas at a flow rate of 1.0 ml per minute. The injection volume was set at 1 microliter with non-splitting mode. A capillary column was used for separation. The initial oven temperature was set at 80 degrees Celsius with an initial 2-minute holding followed by a programmed temperature ramp of 50 degrees Celsius per minute to 280 degrees Celsius and was held at 280 degrees Celsius for 2 minutes. The interface temperature was set at 275 degrees Celsius. The chromatograms of the sample and the mass spectra of vanillin and aldehyde vanillin are shown in the result. Furthermore, for part 2, which is the determination of vanillin in vanilla essential oil by high-performance liquid chromatography. Based on the journal development of validation of NRP-Hplc method for quantitative determination of vanillin and related phenolic compound in vanilla plant folia. The preparation of sample solution can be read as follows. Meanwhile, based on journal determination of vanillin in vanilla from Lampung, Indonesia by high-performance liquid chromatography. The sample preparation was prepared as follows. About 1.5 kg vanilla sample were cured by 3 methods, which was scalding in hot water at 65 degrees Celsius for 30 seconds, drying in the oven at 60 degrees Celsius for 48 hours, and drying in the sun for 20 days and 2 until 3 hours every day. Cured vanilla was fermented and dried in the wind. Therefore, the water content in the cured vanilla decreased from 55 until 65% to 25 until 30%. Then, cured vanilla was stored minimum for 2 months. And lastly, the result of cured vanilla was taken at random pre-extraction. Then, for extraction, the procedure was divided into 3 major steps. The step can be read in the shown diagram. In addition, following are the proportion of standard solution and vanillin content can be calculated using the formula given in the diagram.
Analysis result. Result for analysis of vanillin in white chocolate by gas chromatography. From the chromatogram in journal titled Determination Vanillin and Active Vanillin in Milk Powder by heat step solid phase microextraction coupled with gas chromatography mass spectrometry, it can be taken as example where there is a presence of vanillin with retention time at 9.647 minutes in the sample that has been analyzed. The results show that vanillin with boiling point 285 degrees Celsius is eluted first, followed by active vanillin with boiling point 295.1 degrees Celsius. In addition, active vanillin with higher boiling point will cause the compound to be retained in the stationary phase. Next, based on the diagram shown, each peak shows a component of ion and the height of the peak indicate the relative abundance of the various components in the sample. The heaviest ion in mass spectrum is known as molecular ion, which is at value 151. The relative molecular mass of vanillin is 152.15 gram per mole, where it is close to the highest molecular ion value of the compound shown. Result for determination of vanillin in vanilla essentials oils by high-performance liquid chromatography. All of 21 phenolic compounds were identified by comparison of its retention times, UV spectra, and by co-injections with standards. The authors are successfully run the experiment with using a combination of ACN or methanol and 0.2% of acetic acid as a mobile phase, as it allowed to separation of maximum 21 phenolic compounds. After that, they got detected 10 phenolic compounds, including vanillin at peak number 7, after decided to quantify in the vanilla pots.
Discussion. Retention time is the time for the analyte to pass through the column between the sample injection and an analyte peak reaching a detector at the end of the column. Qualitative analysis reveals the identity of the coordination compound in a sample, while quantitative analysis reveals the amount of each coordination compound in a sample. In the result, retention time tells us about the compound of identity. This is the qualitative analysis. The peak area or height in the chromatogram tells us of how much the compound is there. This is the quantitative analysis. Vanillin and related phenolic compounds in the ethanolic extract of vanilla pods were quantified using the development and validated Hplc method. The concentration of vanillin compared to others was found to be the highest. The table below shows the evidence of what was found.
Conclusion. In gas chromatography, we managed to identify the component vanillin that present in white chocolate. The retention time of present of vanillin is 9.647 minutes. Also, ethyl vanillin have a higher boiling point than vanillin, which is 295.1 Celsius. The relative molecular mass of vanillin was 152.15 gram per mole, which is close to the highest molecular ion value of the component we showed in the result. In high-performance liquid chromatography, Hplc, we managed to determine vanillin in vanilla essential oil by Hplc. Vanillin is present with retention time at 14 minutes in the sample. Also, 10 phenolic compounds including vanillin detected at peak number 7. Hplc method offers a more accurate means of determining vanillin in vanilla essential oil. The present research has some limitation. Vanilla doses in white chocolate were determined experimentally. Future research should look at how adjusting the vanilla content. Next, via application, non-sensory and sensory research methodology should be better integrated.